Alright, hello. Today we've got this lovely integral going from 0 to 1 of the square root of 1 minus the square root of x, all integrated with respect to x. So we're going to use a u sub, and we'll have u is equal to the horrible bit inside the first square root, i.e. the square root of x. So we could rewrite this as x is equal to u squared, and then when we differentiate, we'll get dx du is equal to 2 lots of u. Beautiful. So let's look at the limits. If x is equal to 1, then the square root of 1 is also 1. So we have that u is going to be 1. And similarly, when x is 0, the square root of 0 is 0. So we have that u is also equal to 0. So our limits don't change, makes things nice and easy. So let's plug in some things and see what pops out the other side. But before we do that, we'll rewrite our differential. So we have dx as a subject, and we'll have then that's equal to 2u du. Lovely jubbly. So let's go and plug everything in. Our integral then is going to be equal to the integral from 0 to 1 of 1 minus u, all square rooted, multiplied by 2u du. Now then, to attack this, we'll use integration by parts. The bit to differentiate we'll have as the 2u. So when we differentiate it, that will give us just 2. And the bit to integrate we'll have as the square root, but we'll rewrite it as 1 minus u to the half. And now we can use inspection to see that it's going to be something along the lines of 1 minus u to the 3 on 2. If we differentiate inside the bracket, we'll get minus 1. So to get rid of that, we need another minus. And the 3 on 2 would come to the front. So to get rid of that, we need the reciprocal of 3 on 2, i.e. 2 on 3. So when we stick this all together, I is going to be equal to u times v. So minus 4u on 3 multiplied by the bracket to the power of 3 on 2. And this will be evaluated between 1 and 0. And then we'll take away the integral of u dash v. So the minus from the v will cancel off with this minus to make a plus. The 2 times 2/3 gives us 4/3. And then the bracket 1 minus u to the 3 on 2. And this will be integrated with respect to u. If we just plug in our numbers into the first part over here, this little bracket, well, when we plug in 1, we'll have 1 minus 1 is 0, and everything's multiplied together, so the whole thing is 0. When we plug in 0, we'll have 0 on the front, and because it's, again, all multiplied together, it will be 0 again. So the whole thing is just 0. This integral will come with us, 4/3, 1 minus u to the 3 on 2 du. So to solve the second part of the integral, we'll do inspection again. So we know it's going to look something along the lines of 1 minus u to the 5 on 2. We still have our 4/3 at the front, so we'll whack that there. And if we think about sort of differentiating this thing, again, the minus will appear. So we'll have a minus on the front. And then we're also going to have the 5 on 2 would come down. So that's going to make it a 2 on 5. And this then needs to be evaluated between 1 and 0. So plug in the 1. Similar to last time, when we plug in 1, this bracket will become 0. Anything multiplied by 0 is 0. So we'll have 0 there. Take away when we plug in the 0 itself. So 1 minus 0 is 1. 1 to the power of anything is 1. So we have 1 multiplied by minus of our coefficients here. Minus because of this bit. So computing this coefficient then, we're going to take away 8 over 15. And now the 2 minuses will make it into a plus. So the final answer is just 8 over 15.